guys, welcome back to my new video. In today's video, I'll solve shortest path in weighted undirected graph. Go to problem statement. In problem statement, you have given a weighted undirected graph having n number of vertices number from 1 to n and m number of edges along with their weights. And you have to find the shortest path between the vertex 1 and the vertex n. And if there exists a path and return a list of integers whose first element is the weighted of the path and the rest consists of the nodes on path. If no path exists, then you have to return a list containing single element minus 1, and the input list of edges is as follows like this, and denoting there is an edge between a and b and w is the weight of the edge of that edge. Okay, and note that the driver code will first check if the weight of the path returned equal to the sum of the weight along with node of that path. If equal, then it will output weighted of the path or else minus 2. And in case in list contain only single element means minus 1, then it will simply output minus 1. Okay. First, you have to understand what is undirected graph. Undirected graph means the graph which have not mentioned any direction, means there is no any more direction, like this graph is directed graph because they are all mentioned direction of each edges. Okay, but in undirected graph will be like this, like this type. Okay, this type means there are no arrow or no direction. Okay, first understand first example. In first example, they are given number of vertices 5 and number of edges 6, and the path is like, and this one will we have to maintain first two value and last value is weight of the of that edges. It is weight. Last value is weight. Okay. First value is 1 2. Okay, means 1 to 2. 1 to 2. This is 1, this is 2. Okay, and the weight is 2. Okay, fine. Now next 2 5 5. Okay, means it will go to 2 to 5 like this. This is 5, this vertex is 5. Okay, 5, and what is the weight? 5. 5. Then 2 3 4. Okay, 2 will go right down here. This what is 3. What is the weight? 4. Weight is 4. Now 1 4 1 means come over here 4, and what is the weight? 1. Okay, now 4 3 3 means 4 will add to these vertices 3. 4 3, what is the weight? 3. Weight is 3. Okay, now 3 5 1 means 3 will add to 5, vertex number 5. Okay, and what is the weight? 1. Okay, now these are the undirected graph. Graph will like this. Okay, after presenting, now we have to check our source to destination shortest path. Our in problem statement we have given that we have to find from number one number of vertex, means number one vertex to last vertex. Here last, what is the highest and last vertex? 5. Okay, so we our last destination is 5. Source is 1 and destination is 5. Okay, now in this graph check which path take short path to reach 5. Which edges if we go right this path 1 4 3, 1 4 3, right this path, this path, this takes two vertices, means what is the total with 3 plus 1 3 1. Okay, 1 3 1 3 1. Okay, and sum of these 5 5. Now if we go to this path 1 2 then 5. What is the weight sum? 2, 2 plus 5. 2 plus 5 means 7. Okay. Now, in this example, you can see the shortest path is, what is the lowest and shortest? 5. Okay. 5 is smaller than 7. So, in this case, output will be 5. Output will be 5. Okay. Now, go to next example. In next example, number of vertices are given 2 and edges are 1. There are the path. Okay, write down like the graph will be like this. Number of vertices 2. Okay, like this is not one vertex. This is one vertex, and this is edges. This is edge. This circle edge. Now, how many number of edges? 1. Okay, here are 1. And what is the weight of this? 2. 2. 1 and 2. 2. So there are only one edges and total number of with this sum is 2, because there is only one integer value. So it will return output 2. Okay. Now go to next example. In next example, number of vertices 2 and edges are 0. Okay, and there is no path given. And in problem statement they have mentioned if there is no path given, then that will return -1. Okay, no need to worry. That's it. Now go to brute force approach. The brute force approach will be, first we generate all possible paths from node 1 to node n, means till last node. What is the last node? That, till that. Then we calculate the path weights, means we calculate each path weight and then we sum of the total weight. Then we select the shortest path to compare weights all other path and select the path with minimum weight. Okay, with minimum weight. Then we go to code. In code, first we represent, create a graph at as an adjacency list. So we create this graph, create a for loop. Then we initialize distance array, and then we create a heap variable to store distance and vertices. Then we reconstruct a path to create a parent variable. Then we create a while loop to check the path which is the shortest. Okay, so we create another if and a a for loop and then another if. Okay, and this for loop will explore the neighbor path. Okay, and this if condition will check new path if we find any shortest path will exist or not. Okay, and this is part 1. This is part 1, and another part is this. Okay, and in this, it this if condition check if no path in the vertex, then it will return -1. In example, last example we have find this, if no path are find, then it will return -1. Then we reconstruct the path from n to 1. Then we reverse the path. Then we return the path and its total with this. It will return total with. Okay. And what is the time complexity? Time complexity is O of m into log n. Here m is number of ages. Number of ages. And n is vertex, number of vertex. Okay, and the algorithm uses a priority queue, mean heap, minimum heap to select the vertex with the smallest tentative distance. And each vertex can be added and extracted from the priority queue, and which takes O of log n time. Okay, therefore the overall time complexity will be O of m into log n. That's it. And the space complexity will be O of n plus m. Here already said n is number of vertices and n is number of edges. And this O of n stored the distance of array and priority queue, and O of m will store graph representation and adjacency list. Okay. Now go to code. Already discussed this code. Now compile and run. Now submit. We solved today's problem. Hope so today's video is helpful to you. Please like and subscribe our channel. See you in next video. Still in Tata. Bye.